interest is where each new period you are earning interest on the interest from the last period. So we treat this like an increase question. You have done this last lesson, but what we're going to do is make it look like a formula this lesson. Just like we had a formula for simple interest, we're going to have a formula for compound interest. So you need to make sure you write this down. The rule is A equals, remember A was our final value, P. Now to the principal we multiplied by 1 plus the interest as a decimal, didn't we? So like if it was going up by 9%, we multiplied by 1.09. So what we're going to write that as, it's going to be 1 plus. Okay, so when we do the increase, we're adding on the interest as a decimal. Does that make sense why I've got that 1 plus? That's what tells me that's an increase question. Okay, so I've got 1 plus, what am I adding? What letter? R. Okay, I'm adding the rate. Remember the R must be as a decimal. Okay, so if my interest rate was 7%, that would be 0.07. Now the 1 plus R, that's what we were doing over that example where we had 1.05. That was 1 plus the 5% as a decimal. And then we put it to a power of n. What was n again? How many periods? Okay, so just in case you want to write that down, so A is the final value. P is the principal. Now the R and the N we've got to be really careful with. So far, R and N have always been years. It's going to get a bit trickier when it's not years. Okay, so R is the interest rate per period as a decimal. Okay, when it says interest rate per period, everything's been really easy so far because it's all been years. But when I start doing interest rate for 1 month, for example, I'm going to have to start dividing by 12 to make sure my interest rate is per whatever I'm compounding. Okay, and my N is not my number of years, it's my number of periods now. So if I said 7 months, N would still just be 7 if I was doing monthly. Okay, so in simple interest, we always changed N and left R alone. Now you're going to have to check that both of them are true. Okay, that both are correct for that question. So we'll get to that in an example, but just be aware R and N are getting a little bit tricky. Now depreciation, what do you think when you think the word depreciation? Can anyone think of where we've heard that word before?
Nope.
Has anyone heard the word depreciation before?
Nope.
Sam has.
Yeah.
You want to tell us anything about the word depreciation?
I don't know the name, but I've heard it.
You've heard it. Well, that's a start. Depreciation is where values go down. Okay? So you may have heard it around tax time where people claim the depreciation on particular items. So you might not be able to claim, we were looking at tax the other day, you might not be able to claim the full value. If you're at a factory and you bought like a special equipment that cost $100,000, you can't claim that in one tax year as a tax deduction, but you can claim the depreciation on it. Depreciation means it loses value each year. So for example, a car, the year you buy it, is going to be worth more than the next year. Okay, and every year it's worth a little bit less. It keeps going down and down each year. So that's what depreciation is where the values go down by a certain percentage. So if compound interest is an increase question, depreciation is the decrease question. What do we do for a decrease question? So here we added the percentage. What we do for decrease? We just minus it. Okay, so it has its own separate formula with a minus rather than a plus. So it's not really that different, is it? Okay? A equals P1 minus R to the power of N. So if something was depreciating by 10% every year, then you're doing 1 minus 0.1, which is going to give you 0.9. So this is going down each year. Now the nice thing about depreciation is we don't really care how much it goes down in a month. We pretty much always do years. So that makes those questions a little bit easier. Okay, it starts off with the same, so A is still the final value. P is still the principal or initial value. R is still the interest rate. Per period as a decimal. And N is the number of periods. So it's exactly the same definition, but the questions tend to be easier because they don't muck around with R and M and just leave them as years, making it a little bit nicer. Alright, has everyone got that down?
Yes.
So this is not new, you did this yesterday, we're just making a pretty rule for it. Okay? So we have this example about Callum. Callum invested $10,000 with Mental Bank. The bank pays interest at a rate of 7% compounded annually. So this is compound interest, so we're going to know the rule. A equals P, 1 plus R at the end. Not that exciting. So this is exactly the same sort of questions we did in the quiz. So this is
What quiz?
a quick quiz that we just did 2 minutes ago, remember?
Yeah,
Yep.
that.
So the principal is the amount of money invested, which is 10,000. Now in the brackets I'm doing 1 plus R. Now if it's 7% and everything's working annually, what's going to go in here? What is R?
Right.
0.07, okay? 7% is 0.07, so 1 plus 0.07 is just 1.07. Is everyone happy to do that in their head?
Yes.
If you are not happy to do it in your head, that's fine. Write 1 plus 0.07, I don't mind. And how many years we're investing it? 5 years. Grab a calculator, type it in, what do we get? Charlie, are you typing that in or are you typing in something not appropriate?
What? No.
Should I type it in? Come on, someone can type it in faster than me.
What's the calculator?
Oh, I'll look and type it in. Are we nearly there? Done. What's the answer? The loud voice.
1485.5.
Okay, I couldn't hear because Charlie was chatting. Sorry.
1485.52.
Okay, and then part B says how much interest was earned. What do we do for that, remember?
U minus the new value of.
Yep. So the interest is just the 14,025.52. Oh, that's a dreadful 5. That's a 5. Minus the amount of money you originally invested. Is everyone happy with that?
Yes.
Yes.
Why do you add 1 to the rate?
Here, because it's an increase, we want to have a full amount, the original, which is 100%, plus 7% more. Does that make sense? Okay. Now, in the next example, we have Victoria. She's investing 6,000 at 8.4% for 4 years. The problem is this question got a whole lot more difficult with this one word.
Monthly.
That makes everything way more difficult. I need to be really careful that both N and R are monthly. Okay? So we start with the same rule. Okay, and the P is really easy. It starts the same, 6,000. 1's okay. Now when I get to R, I can't put in 0.084. Because that's for the whole year. I only want 1 month. What should I do?
Can you just divide it by 12?
Just divide by 12.
You said it's really hard.
It's not that hard. You just got to be careful. So I tend to just write it like that. Is everyone happy with that?
Yes.
Yeah.
So that interest rate, I can't use a whole year's interest because it's only 1 month at a time. What about the N? The N is the number of periods.
Still a four.
4.
No,
Or would it be
I thought about 12 as well.
48?
Charlie's got it.
Oh! Didn't see that coming, did you?
How'd you get that, Charlie?
It's easy, just do 4 times 12.
Okay. Shh. So Charlie times by 12. Does that make sense? Why would I do that?
Because it's the answer.
That's right. It's the number of months I have. So 4 was how many years I had, but he asked for how many months. So it's going to be 12 times as many months. Okay? So if it's monthly, I'm taking my interest rate dividing by 12, and I'm taking my number of years and timesing by 12. If it was weekly, it'd be 52. If it was 6 monthly, it'd be 2. Always read the question carefully. Sometimes they might say 8.4% per annum for 17 months. So it might already be in months, so you might not have to change it. So you really, Bryce, you really need to check the question carefully that both R and N are in whatever you are compounding, which in this question was monthly. Then I just grab a calculator and I type it in. Who's going to volunteer to type it in this time? Okay? You've lost it.
Wow!
Oh, it's a race.
8,300.
I told him. No! It's wrong, miss.
Yeah, it's not that. I need. Oh.
No, it's right.
It's wrong.
It is right.
It's wrong.
It's so wrong.
It is wrong.
It's 8,386.
It's wrong.
Miss.
Why did I get a 2
Ah, surely I got that.
Okay.
It's wrong.
Too fast. Alright, one more example. Last example.
Looks really complicated, doesn't it?
Last example.
Yeah.
Alright, we like these ones.
Naomi.
Naomi bought a computer 3 years ago for $5,680. She's a graphic designer. She assumed the value of the computer would depreciate at a rate of 25% per annum. What is the value at the end of 3 years? So,
The money would go down so much. It goes down 75%.
I have the minus. No. It doesn't go down 75% because each year it goes down 25% of the
That
year before.
sucks.
It's not that hard a formula. Come on. So 5, 6, 8, 0, 1 minus 25%, which is not 0.25. Are we racing for the calculator, are we? Racing your calculator skills, typing
Actually,
it.
so slow.
What's the answer?
It's 2396.25.
What was it?
2396.25.
Point.
25.
I think Charlie beat.
Yeah, Charlie's still
Seriously.
out.
Alright, Jane, could you stop the video? That's it. Your turn to